analyzing constantly the this is the part where I like first time actually I can smell the emissions, but I never see them until I get this graph from the measuring computer. And here each colorful line is a different mass of a compound, different molecular mass, and each of these peaks is when I close the chamber and start to draw air from the chamber to the instrument. So let's analyze this data and see what it gives. The first finding that we had from this work was that there were actually a lot and lots of these monoterpics coming from the Scots pine stems, which should not be surprising in the sense that the conifer trees, especially pines, contain a huge amount of resin within the stem, and this resin is 1/4 composed of these exact monoterpics. So when they escape from the resin storages, they cause big emissions of monoterpics to the air.
4 minutes.
Yeah, thank you. Now, the second finding was that we were interested in seeing how the drought affects these emissions, since we were in these drought-prone forests, and we saw that when there is a lot of water in the soil, when the soil water potential is close to zero, there are more emissions, but when the soil water content decreases, the emissions decrease from the stems. But there was also these surprise peaks of huge emissions in the end of summer, even though there was very little water available in the soil. So this we suspected that may have to do with these herbivory or parasites, some biogenic stress that we just didn't see but was existing, and that caused the trees to try to defend themselves and push out lots of these monoterpics. I'm going to conclude with this, and the conclusion from this study for now is that yes, actually the tree stems can be important sources of these volatile compounds, and which is actually really nicely illustrated in Rasa's work, that even this part of the tree that we usually find a bit of passive part